Imagine a computer, not the one on your desk, not the one you use for everyday tasks. Imagine a computer more powerful than all computers combined. This isn't science fiction. This is quantum computing, a groundbreaking technology. Classical computers, the ones we use every day, are like light switches. They are either on or off. They use bits which are either 0 or 1. Quantum computers are different. They're like dimmer switches, offering a range of possibilities. They use qubits, which can be 0, 1, or both at the same time. This duality is what makes them so powerful. This both at the same time idea is where things get really interesting. It opens up new dimensions of computing. It's the key to quantum computing's power. The potential is immense. It allows these computers to tackle problems that would take classical computers billions of years. Imagine the possibilities. We are on the verge of a computing revolution. A new era is dawning. Quantum computers will change the world. They will redefine what's possible. Are you ready to explore this new frontier? The future is here. Quantum computing is more than just faster processing. It's a fundamentally different way of thinking about information. Let's break it down. Classical computers store information as bits, represented as zeros and ones. Think of a light switch. It's either on or off. Quantum computers use qubits. Qubits can be 0, 1, or both simultaneously. This is superposition. Imagine a coin spinning in the air. It's not heads or tails until it lands. That's the power of superposition. Now picture two of these spinning coins, linked together. If one lands heads, the other lands tails, instantly. This is entanglement. Entanglement allows qubits to influence each other instantly, no matter the distance. This bizarre connection is what makes quantum computing so powerful. The world of quantum mechanics is strange and fascinating. It's the opposite of our everyday experience, defying our common sense. But it's the key to unlocking the potential of quantum computers, which promise to revolutionize technology. Imagine a single atom, the building block of everything we know. In the quantum world, this atom can be in two places at once, a phenomenon known as superposition. It can be both a wave and a particle simultaneously, a duality that challenges our understanding. It's as if a basketball could be both bouncing and rolling at the same time, an impossible feat in our macroscopic world. This is the counterintuitive reality of superposition, a cornerstone of quantum mechanics. It allows quantum computers to perform multiple calculations simultaneously, vastly increasing their efficiency. This parallel processing is what gives them their speed advantage over traditional computers. Quantum entanglement adds another layer of complexity and intrigue. Two entangled particles are linked even across vast distances, behaving as a single entity. Change one, and the other changes instantly, no matter how far apart they are. This spooky action at a distance, as Einstein called it, is crucial for quantum communication and computation, opening new frontiers in science and technology. Section 4. Quantum computers in action. The potential applications of quantum computing are vast. Let's explore, a few examples. Drug discovery could be revolutionized. Quantum computers could simulate molecules with incredible accuracy. This would allow scientists to design new drugs and therapies much faster. Imagine curing diseases like Alzheimer's or cancer. Cryptography, the science of secure communication, would be transformed. Quantum computers could break the encryption we use today. But they could also create new, unbreakable codes. Climate change models could become far more accurate. Quantum computers could simulate the Earth's climate with unprecedented precision. This would allow us to understand and address climate change more effectively. These are just a few examples. The possibilities are truly limitless. Section 5. The future of quantum. Quantum computing is still in its early stages, but it holds immense promise for the future. Building these machines is incredibly difficult, requiring precision and advanced technology. We need to control the tiniest particles in the universe, which is no small feat. One of the biggest challenges is decoherence. Qubits are extremely fragile and sensitive. The slightest disturbance can cause them to lose their quantum properties, making stability a major issue. It's like trying to build a sandcastle in a hurricane, where the environment is constantly changing. Another challenge is the need for specialized programming skills, which are quite different from traditional coding. Programming quantum computers is completely different from classical programming, requiring new ways of thinking. We need to train a new generation of quantum programmers to meet the demands of this emerging field. Despite these challenges, the future of quantum computing is bright and full of potential. The field is advancing rapidly, with new discoveries and innovations happening frequently. New breakthroughs are happening all the time, pushing the boundaries of what we thought possible. Quantum computing has the potential to change the world in ways we can only imagine. It could solve some of humanity's greatest challenges, from climate change to complex medical problems. It's a journey into the unknown, and it's just beginning, with endless possibilities ahead.